Hey, we've had some boring containers, but here are some more interesting ones. And I reckon if we can get through this presentation and the next one, it's party time. And we need this party. We've worked pretty hard here. Let's have a look at what we're doing. We're finding volumes, amount of space, contained in a 3D solid. But we're interested more in more interesting solids here. Hemisphere, pyramid type solid here. I think I need to have that trip to Egypt. I don't know, but I don't know what that's got to do with volume, but it keeps reminding me I've got to get out there. Anyway, let's go down and see how we find volumes where you can see they're tapered. Hey, this idea of cutting parallel to there and the same number of squares all producing the same number of cubes on every slice, it isn't going to work, is it? Because it's tapered. Coming up here, it's getting skinnier and skinnier. The number of squares going up there is decreasing. So how do we handle that? Come on down and let's investigate that now. And here, unfortunately, I've got to give you a rule, and that is that cones and pyramids take up exactly a third of the space of a cylinder or prism with corresponding base and height. Oh, okay. Now that takes some time, and that goes back to more Year 12 work to actually prove that. The volume of a tapered solid. So I'm going to ask you, so that you can do these interesting shapes, to just accept this, unfortunately. It's beyond this level now to prove that the volume is a third of the space of a cylinder or prism. That is a third of the area times the height. So you might remember that the area of, what can we do, a cylinder here is easily done. It's just it's just not the third. It's the area of the base, pi r squared times the height. Only that's not going to be the case if you've got a cone sitting in there. Okay, it actually takes a third. Okay, so it's a third of the area of the base times the height, which is a third pi r squared h. And that sort of volume thing is going to come to calculus in Year 12 in those cases. So what about a rectangular base pyramid? It's a third of the area of the base times the height. This time we're taking that as if it's coming out of, what do we got here? I have trouble actually drawing this one, I think. A third of the, just get rid of this one, of the rectangular prism here. Well, actually, yep, a rectangular prism, because that's rectangular on the end, and then it's tapering in to that point at the top. So it's a third the area of the base times the height, because we're thinking about, that's up the top there, thinking about the pyramid as having a square base, and it's a third the area of the base times the height of the equivalent uniform cross-section body, which is, in the case of a cone, the cylinder. Continuing this up here, it's a third of that. Base times the height. Do you get it? I would like to be able to show that to you, but it's a little bit complicated there with some calculus and stuff, so we're going to have to leave that at this stage. So come on down and let's have a look at some examples from Pearson's. A few screen clippings from Pearson's now. So here is a cone. So the general formula, I'd prefer you put a third area of base, not A, times the height. And then the base is pi r squared times the height, just making sure of the units. They've got to be centimetres, yes, 12 and 35. Where it's R, check that you're using R and you haven't taken a diameter from the problem and then going to 2 decimal places on your calculator. And obviously here is a pyramid, so it's a third. Again, I'd prefer you put third the area of the base times the height and put in the numbers. The base is square, so it's L squared. Let's just check that picture up there. Oops, come back here, he's running away. So that's a square. See these symbols here mean they're all the same. So it's 1/3 by 4 squared by the height. And just check, this was centimetres cubed, this was metre cubed. Check those details there, get the units right. Come on down and let's have a look at some spheres now. Spheres, of course, are three-dimensional, so you're not quite getting the 3 dimension there, like a tennis ball type thing. The formula involves pi again, and you're going to have to accept this one. You can prove this one with calculus, that's for a couple of years' time from your course. It's 4/3 pi r cubed. Make sure you use the radius and you don't get fooled by them giving you maybe the diameter. So if the diameter is right through there, let's say it's 10 centimetres, then you must halve that. Must use just the radius for this formula, which would be 5 centimetres. So be on the lookout for that one. Okay, come down and let's have a look at using that formula. There's a sphere. Oh, they've done it to you. That's a diameter. You're going to have to halve that in this formula to get the radius there. It's halved. So write down the formula. Then you've done this division now. Put in the numbers. State the units carefully. Very good. Go through the same process. It's a matter of identifying the right formula and looking at the units and getting the quantities correct. All right. Here's another one. Here's a composite solid, one with something sitting on top of the other, and we want the volume. So here it's going to be the volume of the hemisphere, plus, they put it the other way around, plus the volume of a cylinder. So the volume of a cylinder, this is uniform cross-section. Remember, if you slice it, centimetre down every time. The cubes that will fall out is the number of squares on a cross-section, pi r squared, times height, the number of slices, plus here, the volume of a sphere is 4/3 pi r cubed, but you've got a hemisphere, half a sphere. Right, so can you see that top bit? It's all 3D, it's around there. There's not a very good sphere here. You've only got the top half of it. So it's a half of the volume of a sphere, which is 4/3 pi r cubed. Okay, so putting the numbers in. Watching for R, yes, they've given us R, not D. It is 16 by the height, and just checking the units, centimetres cubed. All right, so you can put all that on the calculator in one entry, if you're careful, using brackets where necessary. Okay, let's go down and look at some problems. You should crank all these out, I think. Just look at the diagram, make sure of the units, be careful there, check your answers, here they are, and we'll just go on, go through some of the harder ones. Find the volume of each sphere rounded to 2 decimal places. Yep, volume of a sphere, remember, volume of a sphere is 4/3 pi r cubed. Watch out, they give you R and not D. Check that out. Couple of pyramids here on top of each other. What are you going to do there? Okay, set the problem out, showing the whole solution, not just scribble down an answer. Come on down. So some understanding questions, a bit harder now. Okay, bigger numbers here. Looking at the volume of the Earth. Interesting problem. This is an interesting one here. I need to have some of these harder ones, this next level up. Okay, Tetra Pak. I've seen these with juice in them. Not so popular these days. Let's go down to number 9. Uh-oh, going to get hungry here. Don't lick that. Too much sugar. Just let's work the problem out. Leave it for the next person. Okay, and go on now. Just check back up here. Do we have the answers to that? Yeah, they're up there. 8, 9, 10. Here's number 10. And into some reasoning. Good practical problem here in question 12. Wheat silos. good to have a look at that. So have a go at each of those. Try some of the hardest ones. Interesting planet one there. Okay, and I think then just a couple of open-ended questions down there. And some typical examples, okay, of the solutions there. Okay, get busy. There's one more section in this area of measurement. One to go, and then I think we should definitely have that party. But keep your skill level up. Try and do some of the extra problems, some of the harder problems, and I'll catch you in that next presentation. Cheers for now.